Perfect. Yeah, so today I'm going to be talking about a side project that I've worked on for the past couple of months called CommonForms. It's basically the goal is to learn to make PDFs fillable automatically. In my day job, I'm the head of machine learning at a company called Pattern Data, but this is something that's kind of just like fully a passion project. Um, so wrote a paper about this. You're welcome to read it. It's on archive, and the dataset is released on Hugging Face. It's right now a 300 gigabyte dataset. So if you have to have a lot of storage to download it, though I'm pushing a smaller JPEG version soon that reduces it to about 150 gigs. But I think more than reading a paper or like looking at the dataset or anything, the most important thing that I can say is that you can actually like use the tooling and everything. So if you want to understand what this talk is about without having to like listen to any of this talk, just try the tool. You can go to detect.semanticdocs.org and then you can upload any PDF and then it will automatically detect where the form field should go and insert them, or you can run it locally with a pip install. And all the models and code are available on GitHub. But to sort of motivate this, what is CommonForms and what are we trying to do here? So the task is one of that I think of as form preparation. So there's a common document task called form understanding, where you have a filled out form and you're trying to figure out like what the labels are and where like what gets assigned to what label. But a much less common task in sort of the document AI space is form preparation, where you have an unfilled form and you try and detect where the field should go. So you're not actually trying to detect an object, you're trying to detect sort of the absence of an object. And the idea here is that if you need to do this, if you have to fill out any PDF that isn't already a form. So for me, that was my lease actually, like a couple of months ago, I signed a lease and they sent me a PDF that I would have had to print out otherwise. But I can just like upload it to the tool and get it back and fill it, which is very neat. I have a lot of friends who have used this to try and just like get forms fillable. Um, but how do you actually like do form preparation, right? So the idea here is we have some input, we want to render the document. And then given the document, we want to detect this like where the absence, where the field should go. And then we can like, do some little work, some like PDF magic to get those back in as fillable fields into the PDF. But how do we do this? Like data sets don't really exist for this. So basically the core idea behind CommonForms, it's super simple. Can we use existing PDF forms as like a training set? So can we go and scrape the web, find existing PDF forms, and then like render those and train object detectors or VLMs or whatever to detect where form field should go. And so where do you find PDF forms on the web? In this case, we can turn to Common Crawl. And we start with a small set of Common Crawl that was from 1 month that has 8 million PDFs in it. This was released by the PDF Association. And then we need to get from there to like all the fillable forms. And so we do that and we like throw away, 90% of the PDFs because only 760,000 of those forms actually contain some like form, widget, or element. But what I would say is if you attempt to train a form field detector on this set of PDFs, it's going to end up very bad because you actually like the data quality is just like very low. If you just look for field forms that have like an acroform widget or an XFA form. And so what we do is we actually add a bunch of like filtering steps where we attempt to ensure that the forms that we are looking at actually have like high quality prepared widgets in them. So just because a PDF has an acroform element doesn't mean it has widgets. Just because it has widgets doesn't mean it has like meaningful widgets that might just be push buttons or something. Just because it has widgets that might be meaningful doesn't mean that they actually are like usable. They might be super tiny or something, just like errors in the PDF. And so if you do all of this filtering, what you end up with is a set that's reduced by over 99% from the original set of PDFs down to about 59,000 PDFs, which then renders out to about 500,000 pages. And so this is the CommonForms dataset. This is what the paper is about and what the release is about. And the core idea here is that we can do some like dataset filtering to get to like the cleanest possible set. But really what we're banking on is the fact that like quantity is going to be a quality all of its own. And by using 500,000 pages, we can train some high quality object detectors. Now, I know that in the world of like LLMs and VLMs, 500,000 pages doesn't sound like a lot. But if we think back to like object detection data sets in the past, like COCO, which is the big like Microsoft Common Object and Context data set. It's 120,000 pages. So we're looking like we've built a data set at this point that is 4 times as large as like the standard object detection data set, right? But we also like want to look at, do we like, is this going to be representative of like forms on the internet, or like of forms that people actually want to fill? So is there like enough quality here and diversity here that that's going to be a useful set, or is it just going to be like training on exclusively like IRS tax forms, which kind of would be useless? And so we can look at the like breakdown, and CommonForms is like very language diverse. Admittedly, like 2/3 of it is in English, but 13% of it's in Cantonese, and then we have like a bunch of European languages, Korean, and so even though like 1% of it's in Russian, that still means that like 5,000 pages or like 1,000 pages, 5,000 pages are in Italian or Portuguese. Um, so we still have like good representation across a large set of languages. And then we also have very good representation across a large set of domains. Other is sort of the catch-all category, so that is the largest, but we also have 10% of the documents come from government, administrative, engineering. There's no one category that sort of massively dominates. So we are not, thankfully, looking at exclusively English language IRS tax forms. Um, so what can we do with this data? The first thing that we can do is we can train some super simple object detectors. And that's what I did. Basically train some YOLO models, a 6 million parameter model, and a 25 million parameter model. So the first one is FFDNet small, and the other one's FFDNet large, where FFD stands for form field detection. And all this work was actually sponsored by Lambda Labs. It's like super generous of them to basically give like give me like GPU research credits. And each of these models was able to be trained in basically sub $500 on the CommonForms data set, so about 150 epochs for each of them. And the important thing here is that we actually get very high average precision, which I think lends a lot of idea to the sort of construct validity of this task. That means that like when you like given a new form, we should be able to perform really well because we don't really have other baselines for that people have run on this set. So it's really exciting to me to see like high average precision, and I will talk a little bit and like talk in a little bit about some other models that I'm currently training and currently running and sort of what they're looking like. But starting with the sort of dead simplest models, we actually get like very good performance. And I would encourage you, like I said at the beginning, I would really encourage you to just kind of like try it yourself, use the tool, because it's actually kind of astounding to me how good like even like a simple object detector is on a page. This is not necessarily intuitive. For instance, like the distinction between a text field and a signature field relies on being able to read some content on the page. You need to be able to see that it says like signature or like in German, like Unterschrift or something, um, which is which means that like at some point, like your object detector has to basically do some super simple like latent OCR to detect like this is a signature field. And we're seeing like pretty good performance for detection of signature fields. Unfortunately, though, just because we have sort of high average precision on the actual CommonForms test set doesn't mean that that CommonForms is super high quality. And so basically we see like good contract validity, but sort of not perfect. And so I want to sort of talk a little bit about what the limitations of the data set are. The first is that forms are not sort of uniformly prepared by various like people. So for instance, like a lot of forms will have a for official use only section, which might not be like fillable by itself. And so in some cases it is, and that's really useful. And in some cases it's not. And then basically what you're training the model in the cases where it's not is to say, if you see words like for official use, then, don't predict objects near those words. And so if you sort of buy into the idea that these object detectors are learning some kind of like lightweight latent OCR to detect like signatures and stuff, and it might also be learning some negative signal from inconsistently prepared forms that say like for official use only. Another limitation of the data set is this like super common, especially like medical offices, like circle or check all that apply. These are not consistently annotated in the data set. So in some cases they are, right? Somebody will put like a checkbox next to everything when they want to make the PDF fillable for people. And in some cases they aren't, where they kind of expect that you're going to print out the form and circle or check like automatically yourself. And we see a lot of these within CommonForms, which can actually, again, you get sort of a negative signal for like maybe like for don't predict an object here when ordinarily you would want to predict an object there. Another limitation is that we can do a good job of detecting when to use a signature and when to use a text field based on the existence of signatures and text fields in PDFs. But PDF signature fields are kind of a sort of a very weird and cumbersome format. Um, Typically, a PDF signature field involves having a like some special piece of software that is able to sign the PDF by basically computing a hash of the PDF and inserting it into the signature object. And so many people who prepare forms don't use a signature object to make the PDF fillable. They will actually just use a text element, and somebody can just type their name and say, Joe Barrow signing the PDF, because they don't actually require like a full PDF signature. So I've actually had some people reach out about CommonForms tends like the FFDNet models actually will sometimes overpredict text as opposed to signature for certain signature fields. And again, this is like we're seeing really high performance on the actual like on the CommonForms data set for signatures, but sort of limitations in the real world show that actually maybe this isn't the case because the data set is kind of, it's kind of a silver label data set when you think about it. And then another one is scans. So a lot of scans are not prepared as PDFs, so people will just like scan, and it might exist in a form. Like there might be other pages in the form that are prepared, but then the scan itself is just a picture that is not prepared. But again, some of them are. And so when you see a lot of like unprepared scans, this like basically the messiness of the scan kind of again serves as a negative signal for the object detector for don't predict objects in this page, because there are features that point to it being a scan. And I would say that scans are actually currently another limitation of the models, just because of largely because of the data set. And there are ways that you can imagine sort of improving on that. So, dataset augmentation. There are a lot of papers that have done sort of document dataset augmentation to make document AI models more robust to scans. So like RODLA and stuff. But right now, basically, the point that we're at is that these are the dead simplest models that are trained on the raw data. And then the last major source of error within CommonForms is just noisy data. So there are tools that will automatically prepare PDFs and make them fillable. And unfortunately, most of the ones that I've tried, and nearly every one that I've tried, in fact, is just not great. A lot of them are like heuristic space where they'll run maybe a Huff transform on the page and then detect straight lines and say, okay, a text field should go where the straight line is. A few of them actually are pretty good. They'll use some sort of like CNN, like Apple Preview will do this. But basically, people will run these on PDFs. They will get messy form fields, and then those forms, like those messy forms, end up in Common Crawl, and then I process them for CommonForms, and then we end up with like a bunch of forms that have quite messy widgets. And so there is just like a decent amount of noise within CommonForms as well, from basically poorly prepared PDFs. But in spite of that, we're still getting like very high average precision. And so the question is like, what does that mean in the real world? So if we have all these, if we know that there's a bunch of like negative things about the CommonForms data set, but we also know that we're getting like very high mean average precision on our object detection for where widgets should go, does that mean that we're actually getting a useful model? And the most important thing that I think anybody who works in any machine learning context can do is to look at data and look at model outputs. And we just looked at data from CommonForms and saw sort of what the limitations are. So let's look at some model outputs. I wanted to compare with like existing state of the art. And the two sort of that I know of for state of the art were Apple Preview and Adobe Acrobat. Due to some sort of like limitations of how Apple Preview works, it was hard to like render out a fillable form and compare. So I ended up comparing against Adobe Acrobat in the paper. And I just want to kind of like I didn't put numbers in the paper for the performance of Adobe Acrobat, largely because it would have taken like a day or two to run on the entire CommonForms test set, and it would just like chew up my laptop for that day or two. But I did run on effectively 1,000 pages, and I just randomly sampled from those 1,000 to give some like qualitative examples. And I don't necessarily think that the numbers are really important, because if you just look at some of these examples, the difference in quality is very clear. So right, we have some input PDF, and then we have Adobe Acrobat, which I believe I believe that it is heuristics based. And then we have basically FFDNet-S, where we're actually predicting checkboxes. That's what the red things are, and text fields as well. You'll note that this is a signature field down here. This is a signature field down here. This is the case where we predicted a text field, where it should have been a signature field. I also want to say, put some scare quotes around state of the art, because this is state of the art. But one consequence of like sharing this more broadly is that it turns out that there are a lot of people that have kind of worked on similar tasks. It just hasn't been made open research, or the models aren't available. And so there is certainly like some state of the art out there that I simply can't compare against. So I'm just comparing against like the best things that are available to me. And in this case, that's Adobe Acrobat. We can also see like we're not over predicting like fields on, like there's a table here with a bunch of checkboxes. We're not saying there should be some fillable text here on like Acrobat. We are getting signature fields here, very exciting. But sort of as we go through these examples, again, like difference in quality is just very clear. So because we're not using like a heuristics-based approach, we don't actually require there to be like a line to be able to say this should be a fillable text field. And because CommonForms, again, is like very language diverse, we actually tend to work quite well on like non-English languages as well. So these are just sort of blank spaces underneath Arabic text about where a fillable field should go. And like FFDNet-S and FFDNet-L both work very well on this field, on this page. And again, we're able to detect checkboxes, which is something that Acrobat doesn't do. And so we just get like genuinely pretty exciting performance on like even weird and complex pages. So I would really encourage you to like try it yourself, download the models, run it locally. The models are available on Hugging Face, the data set's available on Hugging Face. But if you care about sort of the research takeaways, just a few quick slides on that. The first one is that this message kind of keeps getting beaten into me for document AI, which is that resolution is actually really, really important. For a lot of computer vision tasks, resolution is not typically important. So like current YOLO models are trained at like 640 pix. A lot of like the DIT models, or a lot of like early vision transformers, like 224 or 448 pixel per side. But for documents, like for form field detection, the more pixels the higher your resolution, the more pixels you use, just the better you get. It's effectively like close to free performance just to use high resolution inputs for the task. Now, the CommonForms models were trained at 1216 because it is close to free, but it is not free. You use a lot more GPU memory as you increase resolution. And so my trade-off for performance and capability was to train them at about 1216, which loses a few points in terms of average precision on basically the ablation subset that I was running, but you still end up with a very high performing model. And I think that this like takeaway is the same across, like if you look at the recent DeepSeek OCR paper, this is what the exact thing like they say. I think that most document AI papers in the past several years have some like nod to the fact that high resolution just improves performance across most tasks. We can actually ablate across languages, and we can see that it works generally basically the same across most languages, except weirdly Russian, where we see like a 10-point dip. And it also works roughly the same across most domains, which again is very exciting. It just kind of means that as a consequence of the like domain diversity, we're getting some like just good performance. And then the last little bit I want to talk on is like, what am I working on sort of next? Like, where do we take this like this data set? And the first one is I've been doing some like VLM fine tuning. So basically, if we want to fine tune like Cosmos, we can predict where the bounding boxes should go and like what the type are. And this actually works like really well. So very, very well for complex forms. I was actually a little bit surprised because I think that bounding box prediction with VLMs is kind of a little bit risky compared to like object detectors. But even for complex forms, you're seeing like very good performance. The other one is working on extending this data set for actual accessibility. So not just predicting where the widget should go, but what their labels are. One really exciting thing is that somebody reached out and basically was like, hey, I like sometimes like need a side helper to fill out forms. Um, would it be possible to sort of like link the widgets? And the answer is like yes, it would be possible. I just need to actually prepare the data set for that. So I'm working on another data set called FriendlyForms, which is basically form preparation for accessibility. And then the last one is I think that basically the form understanding project problem of like detecting where a filled value is and how it should associate with a label is the mirror image of the form preparation. And those two things should be unified into like a single task. So the last project that I'm working towards is basically unifying form preparation and understanding. That's kind of a little bit further into the future. Um, and that's all I have.